Picture this, it's the 1800s and I show you this giant machine taking up the whole room, all gears and steam, basically a huge noisy metal thing that does nothing but follow basic orders. Now, what if I told you that someday this very machine would evolve to an extent such that it would think like a human, plan like a human, and even make decisions all on its own? From simple calculator to super smart strategists. Cool, right? Hello everyone, I am Keval. Welcome to my YouTube channel. Today we will trace the journey of how software evolved into AI agents that we are experiencing today. So, computers back then were not as we would usually imagine. They actually started out as massive, clunky machines powered by gears and switches. Starting with the father of computer, Charles Babbage's mechanical designs in 1800s and moving to the vacuum tube machines in 1940s, computers steadily advanced in power and complexity. By the 1970s, smaller and more affordable machines like the Altair 8800 made it possible for people to own the computers at home for the first time. But that's not what we are going to focus on today. Instead, we are going to look at something less visible but just as important, the birth of the software. Yeah, there was software even back then, but forget about touchscreens or typing or even terminals. In the early days of programming was done with punch cards. So basically, you would write your command on a special sheet, hand it over to a key punch operator because, of course, there was a middleman, and they would punch holes into cards. So, one tiny mistake, and you would have to redo the whole thing. Yeah, control Z wouldn't save you at that time. And the storage. So those punch cards didn't just run programs, they data too. That's right, before floppy disk and USB drive, people were archiving data in actual cardboard decks. IBM's first computer, the IBM 701, launched in 1952, was built for scientific calculations, also ran on punch cards. By the way, fun fact, back in the punch card days, people drew a diagonal line across the top of their card stacks. So if the cards got dropped, the broken line made it easier to put everything back in order. Old school version control. It was slow, bulky, and kind of a nightmare, but it laid the groundwork for everything that came after. And honestly, there's something kind of charming about this programming being a hands on paper punching craft. So, next time your code editor crashes, just be glad you don't have to carry your bug fixes in a shoebox. Alright, let's rewind to the 1980s and 90s, a time when computers were going from beige boxes to game changers. Hardware was evolving fast, but it was the software that really made people fall in love with their PCs. Let's start with the word processors, the quiet hero who replaced typewriters. So before fancy apps and cloud docs, we had the classics like electric pencil. It's not what you think. It was the name of the word processor software. Released in 1976, it was one of the first word processors and even introduced word wrap, meaning the text would actually move to the next line instead of just running off the screen. Mind blowing back then. Then came the word perfect and word star, both big names in 1980s. Again, a fun fact, WordStar was used by George R. Martin to write Game of Thrones. Just a fun fact. And then there was our beloved Microsoft Word, launched in 1983. It started on Unix, but eventually made its way to MS DOS and Windows. Suddenly, you would see bold, italics, and layout on the screen before printing. Revolutionary stuff back then. By the 90s, Word was dominating offices everywhere. Now let's talk about spreadsheets, the magical grid that made math actually kind of fun. The very first spreadsheet program wasn't Excel, it was called VC Calci. Launched in 1979, it was called as the killer app for Apple II because people bought the computers just to use one program. It turned boring paper tables into live editable datasheets. Then came the Lotus 123 in the early 80s, which basically wiped the floor with VisiCalc. It combined spreadsheet databases and charts all in one, and it became the go-to business tool during MS-DOS era. Then came the iconic Microsoft Excel, which was released in 1985 for the Mac and in 1987 for the Windows. By the mid 90s, thanks to the sleek interface and features like pivot table and Visual Basic scripting, Excel had taken over the world of data crunching. Next up in our line is the operating system, the heart of the hardware. In the early 80s, MS-DOS ruled the scene. It was the command line based, which meant you had to type everything out manually, which wasn't glamorous, but it had got the job done. Then came the Windows 1.0 in 1985, basically a graphical user interface layer on the top of MS-DOS. It looked kind of clunky, but it was the start of something big. The real turning point was when Windows 3.0 was announced in 1990. It introduced multitasking, a cleaner interface, and was just way easier to use. And don't forget the Apple's Macintosh, launched in 1984. It brought the GUI mainstream with windows, icons, and the legendary trash can. Yep, dragging files to the trash can was a novelty once. By the way, again a fun fact to the rescue. So the first Mac that was created was of 9-inch screen and 128 KB of RAM. That's smaller than a single emoji file today. Yeah. By Windows 95, Microsoft had fully embraced the GUI, integrated internet support, and made computers way more approachable for the everyday folks. So yeah, the 80s and 90s were huge for software. These decades didn't just bring better programs, they completely changed how we use computers. From writing papers and crunching numbers to navigating windows with a mouse, this was the era that made software very personal. Let's roll into 2000s, a decade where software started to think. Okay, maybe not full blown artificial intelligence, but this is when programs went from just doing stuff to doing stuff smartly. First up, we have is spell checkers. Back in the day, spell check just flagged words that weren't in the dictionary. Typos would be marked as red squiggly line, helpful, but no autocorrect yet. Now, here's where it gets cool. Modern spell checkers started using something called as Levelstein distance, an algorithm found in 1965 that figures out how many chances it takes to turn one word into another. Sounds fancy, but it's basically how your phone guesses you meant tomorrow whenever you type a wrong spelling of tomorrow. Then came the famous natural language processing or NLP, which is like giving spell checkers a brain. Instead of just spotting misspelled words, they now understand the context. So if you write they're going to the store, it knows that you meant they are, because it's actually reading the sentence and not just scanning individual words. Again, a fun fact, some spell checkers today even adapt to your writing style and learn new words over time. Yeah, your computer secretly keeping a dictionary of your weirdest slangs. Next up, we have the search engines, which got very supercharged. I mean, yeah, search engine existed in 90s, but remember Lycos or Alta Vista? No, right? Exactly. Then came Google in around 2000, which was a game changer. The PageRank algorithm was developed by Google, which was again a game changer. Instead of just counting keywords, it looked at how many other sites to a page are linked and how trustworthy those sites were. So now, when you searched best pancake recipe, you didn't end up on a spammy website from 1997. And here's the wild part, Google used links like votes. The more high quality site links to your page, the higher you are ranked. It was like popularity, but for web pages. And then, because of that, we saw the rise of SEO, search engine optimization. Suddenly, everyone wanted to crack the code and get their page to show up first. Some people even tried tricking the algorithms by stuffing their sites full of keywords. In short, the 2000s was when the software stopped being just a tool and started being a little clever. Whether it was helping you write better emails or find doubtful facts at lightning speed, intelligent software set the stage for smart systems that we rely on today. Now, the software wasn't just smarter, it was starting to listen and even recommend stuff before you even asked. Let's start with voice assistants. In the early 2000s, speech recognition wasn't exactly sleek. You could speak a command and your computer would get confused. A lot. Microsoft gave it a shot in 2001 by adding voice control to Office XP. But let's be honest, saying bold this text and having it type bowl test wasn't exactly productivity gold. But everything changed when Siri dropped in 2010. At first, it was just a standalone iPhone app, but Apple saw the potential and scooped it up, making it into iPhone 4S in 2011. Suddenly, your phone could just understand what you meant, not just what you said. It could answer questions, send messages, even schedule reminders, all through natural language. It felt like the future. Meanwhile, Google wasn't far behind. They rolled the voice search on the homepage in 2011, bringing their legendary search engine power to spoken queries. Ask a question and boom, an answer. Other players joined the game too. Nuance released Nina, which was a digital assistant aimed at businesses. Microsoft launched Cortana in 2014. And then Amazon, oh yes, they changed the game in 2014 with Alexa and Echo Smart Speaker. Suddenly, you could talk to your house, like dim the lights, play music, order paper towels, with your voice. By the way, random fact again, Alexa's name wasn't just chosen at random. Amazon picked Alexa because the hard X sounded easier for voice recognition system to detect accurately. Also, it was a tribute to the Library of Alexandria, the original hub of knowledge. These assistants were not perfect, but they marked a shift. Software was moving away from keyboards and towards a conversation. It was the beginning of a new kind of relationship between humans and AI. Next up is the recommendation engines. This is the tech behind the phrase you might also like. Back in the days, early 2000s, Amazon was already miles ahead. They filed a patent in 2001 for their recommendation systems. Why? Because they realized that suggesting what customers might want could seriously boost sales. Two methods that powered these systems are collaborative filtering, where the system recommends stuff based on what similar users liked, and the other one is content based filtering, which looks at what you liked before and finds items with similar traits. Put simply, if you love fantasy novels, it will suggest other books with dragons and sword fights. If other people who liked what you liked also bought a certain book, you will probably see it too. As time went on, hybrid models combined both the approaches, getting smarter and more accurate results. And as data poured in, these systems started predicting what you may want before even you knew what you wanted back then. Think about it: Netflix serving up the perfect show, Spotify building a playlist that you love, Amazon suggesting that thing you didn't know you needed but immediately added to your cart. It wasn't full autonomy, but it was the start of software becoming proactive. It learned your habits, anticipated your needs, and started making choices for you, or at least narrowing them down. Together, voice assistants and recommendation engines signaled a big leap. Software was no longer waiting for commands, it was learning, suggesting, and starting to act on your behalf. AI hit a turning point. Now the softwares were not just responding to inputs, but started to understand, adapt, and even anticipate. What made this possible? Deep learning. So let's unpack that. Before this era, software followed rules, explicit instructions written by programmers. But machine learning flipped it completely. Now, instead of telling software what to do, we trained it on data and then it learned to figure out things on its own. At the heart of this revolution were neural networks, algorithms inspired by how human brain works. This networks consisted of layers of neurons that adjust themselves as they process more and more data. And when you stack many of these layers together, that is deep learning. Why does that matter? Because deep neural nets could now identify patterns, really complex ones, in things like images, speech, and language. They didn't need someone to define features or write rules, they just learned. For the first time, software could improve over time, spotting objects in the photos, understanding voices, even predicting future outcomes based on the past behavior. Let's talk about the milestones that proved how far this tech had come. First up is AlphaGo. In 2016, DeepMind, which is now a subsidiary of Google, developed AlphaGo and shocked the world by beating a world champion at a game of Go. A game so complex it was long thought to be untouchable by machines. Unlike chess, Go relies heavily on intuition and long-term strategy. But AlphaGo, powered by deep neural networks and reinforcement learning, didn't just play. First, it learned to play like a human and then better. Then came our beloved ChatGPT. This large language model from OpenAI showed that machines could write, and not just keyword or slitted text, but full paragraphs, poems, stories, even code. It could take a few words from a user and spin out surprisingly coherent, often creative text. This wasn't just a tool, it was a glimpse into machines mastering language. And in the real world, we saw AI hit the streets literally with Tesla's autopilot. So, Tesla uses a blend of sensors, computer vision, and a deep learning to help cars maintain lanes, manage speeds, and even park themselves. Sure, humans still had to supervise, but the core idea was AI that could perceive its environment and take action in real time. These weren't just science projects, they were working systems solving complex problems. Strategic reasoning in Go, language generation in GPT-2, real world perception in autopilot. Each of these breakthroughs showed how far software could go when it was trained and not programmed. Even with all this progress, these systems were still reactive, powerful, yeah, but they didn't choose what problems to solve. They didn't set goals or strategize on their own. They were impressive within their defined roles but weren't autonomous. The next leap from reactive intelligence to agents that can plan, act, and adapt independently was just around the corner. We have reached the present now, the age of autonomous agents, the next leap in AI. Not just tools, not just assistants, but goal driven software entities that can think, plan, and act on their own. Now let's move to the goal of this video. What is an AI agent? Imagine a software that does not just follow orders but set its own goals, figure out how to reach them, and adapts along the way. These agents make decisions, learn from outcomes, decompose complex problems into subtasks, and execute actions, sometimes without ever needing step by step human guidance too. It's a complete loop. What makes this possible? A mix of reasoning, memory, planning, and powerful large language models under the hood, especially large language models like GPT-4 and DeepSeek, are performing very well for these AI agents. They are no longer just reactive like earlier AIs. They are proactive, able to take broad instructions and run with them, breaking down goals and figuring out the best path forward. Let's look some of the AI agents making this future real. The first one is AutoGPT. You give it a high level task like research market trends for electric cars and it gets to work. It breaks down the task, searches the internet, stores useful information, even writes and run codes all in the loop until the job is done. It's like hiring a digital intern that never sleeps. The second AI agent that fascinates me was released just recently, that is Manas. Launched in 2025 by a Chinese startup, Manas goes even further. It acts like a digital butler, turning users' thoughts into action with barely any input. Planning a trip, managing investments, building a website, Manas can coordinate with all autonomously. The third one here we are talking about is the deep research. So deep research is being implemented by OpenAI. It is just implemented by Gemini. So the part of the ChatGPT Pro lineup, this AI agent specializes in digging deep. It autonomously explores the web, pulls together trustworthy informations, and build detailed reports perfect for when you need in-depth without doing the grunt work. These AI agents are refining what software is, not just the tools that wait for the instructions, but partner in productivity capable of initiative. So static software reacts, but AI agents act. They bridge the gap between passive tools and intelligent systems, working towards your goals with minimal oversight. And I feel this is just a beginning. Autonomous agents are reshaping what's possible, turning AI from a clever assistant into something far more powerful, a kind of a thinking partner in our digital lives. We have come a long way from simple code to autonomous agents, from static logic to dynamic reasoning, but now we stand at a threshold. The road ahead is full of potential, but I do have some questions like how far should we go? How much control should we give? What kind of future do we want to build with these intelligent systems? And I feel the most important question is where do we draw the line? If you like the content, do like, share, and subscribe. Thank you.